So Enigma Machine was used by Nazi Germany in World War II to send their secret coded messages to each other. As you can imagine, in World War II, you would want to send your secret plans in code. So the Germans used a machine called the Enigma Machine, which I've got here in front of me. So it looks like a typewriter. It's pretty much like a typewriter. If I press the letter A, for example, now instead of printing on paper, the letter Z has lit up. So A becomes Z, that's your code. The clever bit is, if I press the letter A again, instead of being Z, it actually changes letter. Now the letter S has lit up. So it will change every time I press the same letter. So unlike old-fashioned codes, things that children do, where you can break these codes by looking for the common letters like E. Looking for the frequency of letters doesn't work with this code.
So how exactly does it work? I mean, it just looks like a wooden box with a sort of typewriter and some extra letters which can light up, but there must be more going on underneath.
Yeah, so all I describe it as is a big electrical circuit. Inside the machine you have a battery, and then that battery is connected to a light bulb. So as simple as you can make something, really. Let's open it up. So this is the inside of the machine. So inside the machine you'll see 26 little light bulbs. And essentially it is a circuit. There are 26 little bulbs all connected in parallel. So if I press a letter, the battery will connect to one of those bulbs and the bulb lights up. The clever bit is the wires move as I type. When I press a letter, the rotor inside the machine moves, it turns one place, click, and inside that rotor it's full of wires. So the wires are moving while I type. Because the wires move, the battery gets connected to a different bulb. So if I do that, I type the same letter again, the rotor will move, that will turn the wires, and the battery connects to a different bulb. And so you get a different letter lighting up.
So I can see three sort of cogs with numbers going around, but only one of them seems to be moving when you're typing. What do the other two do?
Yes, so these wheels at the top, these are the infamous rotors, and the first rotor on the right-hand side, it moves every time I press a letter. When that does a full revolution, it will kick the middle rotor one place. When the middle rotor does a full turn, eventually, it kicks the left-hand rotor one place. So you have a fast rotor on the right, a middle rotor, and a slow-moving rotor on the left. So they're going at different speeds.
So that means that rather than repeating every 26 times, it repeats every...
So if you want to get back to where you started, you would have to press a key repeatedly 17,596 times. 26 cubed, anyway. So each rotor would have to get back to where it started for the pattern to repeat. That's why there's three rotors.
So that gives you a much bigger combination of different letters you can have.
Yeah, so there's a huge number of combinations that you can have to set up the machine. Yeah, so each rotor has 26 starting places. The rotors actually swap over, so you can change the order of the rotors. And we have some extra wires here at the front of the machine. This is called the plug board, and these wires can swap over as well. The plug board alone has, I believe, 100 trillion ways to set that. On top of that, we have these rotor orders and rotor positions, and altogether, it's 158 million ways to set up the Enigma machine. So not only can't you check the frequency of letters, you can't check all the possible settings either. Those are the two classic ways to solve a code. Well, neither of those tricks work.
So this seems like an immensely complicated code. If someone was sending you a message using this, how would you decode it?
So first of all, your sender would type his message into the machine. The letters would light up, and that would give you a code. You would then transmit the message by Morse code, by radio. Now, someone else will have a second Enigma machine, and they will type in the code. And if the machine is set to the same setting as the first Enigma machine, it will decode the message for you. So it's a code and decode machine.
So you can only decode it if you know exactly what the settings were on that original machine.
Exactly. Both machines would then have to be set to the same place, and you would know how to do that because the settings were written down for you on a piece of paper. A big sheet of paper called a key sheet, and for each day of the month, it changed. So for each day, you would have to set your machine again.
So this was something the Germans used, but the English managed to crack it. How?
The Polish broke the code first. They were breaking the code before the Second World War started. They knew Germany was a threat. They'd already started trying to break their Enigma code, and they succeeded. The problem with the Polish methods, they were a little bit fragile. Every time the Germans changed their procedures, the Polish methods stopped working, and they would have to break the code all over again, find a new way to break the code all over again. About 5 weeks before Poland was invaded, they passed their information to the British, and then the British continued their work. Now, what they needed was a more robust method of breaking the code, a way that would continue to work if the Germans changed their procedures, which is very likely. So that's what Alan Turing needed to find. The flaw they exploited in the end was, although it's a very clever machine, there is a flaw. A letter will never become itself. So if I press the letter A, as I was doing earlier, it will change letter. Every time I press it, it could be any letter except for the letter A itself. So a letter never becomes itself. This is a clue. Now, it's not a very big clue, but it is a tiny clue. And that's their starting point for breaking the code.